In this lesson, we're going to learn about attributes. To really use Houdini to its full extent and to be able to create anything, we really need to understand this concept. Attributes keep the information that make up a scene. You can think of them as the properties that every point, vertex, or primitive is storing. It's where everything is kept. Think about the position of every point, for example, or the color, or the UVs, or the normals, or the velocity if it's moving. All that information is being kept as an attribute. I like to think of attributes as tags that you would find, for example, in clothes. If you go to a store and you look through any piece of clothing, you'll find that it has a tag. That tag stores a lot of information about that piece of cloth, and it's unique to that piece of cloth. It says the brand, it says the price, it says what it's made of, it says where it was made, has instructions on how to wash. Some of these attributes are useful for some people, some others aren't. It's the same in Houdini. Some attributes are actually read by Houdini, and whenever Houdini finds them, some nodes will react differently. Well, we can also create our own attributes that have absolutely no meaning for Houdini, and they only do for us. We can look at what are the attributes we have in our geometry by checking the geometry spreadsheet. So if I click right here, you'll find a window that looks similar to an Excel spreadsheet. On one side, we have the point numbers, in this case, from 0 to 7. And over here, we have the attributes. In this case, it says P, X, Y, and Z. And then we have the value of Px, 4.0, 4.1, 4.2. The more attributes we add, they're going to appear here, and their values will be drawn here. Since the data from one node travels down to the next one, and some attributes are recognized for Houdini, then we need to find the right attribute that when it goes from this copy to points to this other one, is going to create a box that has a different size. And for that, I'm going to create a node called attribute expression, and this will allow us to create a new attribute. By default, you'll see that nothing happens, and right now it's just affecting the position. If we choose on this drop-down menu, we'll see that there are several attributes that are already defined for us, and these are all attributes that are recognized by Houdini. For example, P represents position, V represents velocity. The one we're most interested in right now is scale, and the attribute for that is called P-scale. So if we change it to that, we'll see that suddenly our boxes are gone, and the reason for that is that the P-scale is by default set to 0, so that means that all our boxes that are being copied here are going to have a scale of 0. If we click on this drop-down arrow, we'll find there's a lot of presets to change the value of that attribute. If we change it to a constant value, you'll see this parameter gets enabled, and we can now change the size of every box. So what is really going on here? If we select our attribute expression and we look at our geometry spreadsheet, we can see that every point is getting a P-scale value. And what happens with that is that when it goes into the copy to points, Houdini recognizes this P-scale attribute, and it knows that it has to scale the box to match that size. So how do we know what attributes matter? How do we know what attributes do this type of things? Well, if you click on this question mark over here, it can be on any node. It's going to open up the help of Houdini. And if in the search we type point attributes, there should be a page here, copying and instancing point attributes. If you click here, you'll have a list of all the point attributes that are recognized by Houdini, and it says what type they are and the description. So for example, P-scale is a float, and it sets the uniform scale. Later on, we're going to deal with normal and with up, which deal with the orientation. We can see this says the Z-axis and the Y-axis. And we can find again V that we saw in the drop-down deals with velocity, P deals with position. Alright, but so far, all we need for now is P-scale, and we want to change this for every rock. So if we go to the drop-down, we'll find that there's one preset called random. And if we select that, it's changing this Bex expression to be rand, and between brackets, it says @lm_num. What that means is that it's getting a random value for every element number. And in this case, the element is a point. So the way this works is that Houdini is getting a point number, so 0, 1, 2, 3. And for each one of those numbers, it's returning a completely random value between 0 to 1. So if we sort P-scale, if we sort this column by clicking on P-scale, we can see the biggest one is very close to 1. And if I click again, This is the smallest one, is almost 0. You can click on here to sort by point number. And if we look now at the result, we're getting different sizes for every rock. We can even take our system a step further if we add another p-scale. If you have a look at our setup, there's 2 copy to points. If I visualize the first one, right now we're copying the lines, which have the points where the rocks will be copied. And right now, every pile of rock has the same height. If we actually copy this node and paste it over there, I'll just go into do Control Copy, Control V, Control C, Control V, and then I'm going to drop it down between the scatter and the copy to points 1. And it's doing the same thing. It's changing the size of the lines, and they're going from maximum size of 1 to the smallest, which is 0. And if we look at our result now, we'll see piles that have a lot of rocks, and we'll see others that have very few. So now we know that having an attribute called p-scale on our points that we're going to use to copy will cause the copy to points to change the scale of an object. Now, what about other nodes, like for example the scatter? The scatter has this attribute called density that by default is turned off. And if we turn it on, we'll see that it errors out. We middle mouse click, you can see the error, and it says invalid point density attribute specified. The reason for that is that the attribute doesn't exist, so it can't find it, so then it's giving us an error. For that, we need to create it. I'm going to move the grid a bit up to add some space, and I'm going to create a new attribute expression. I'm going to drop it in, and this time we don't want to create one of these attributes. We want to create a custom one. So I'm going to choose on custom, and I'm going to change the name to density, which is what this scatter is expecting. Now, it doesn't have to be density. It can be called like grow_area. The only thing that matters is that these two have to match. So grow area. But I'd say most of the times, if you're going to be sharing your scene or if you're working with other people, it's a good idea to use density, since everyone expects that density is going to be used by the scatter. And by default, this is creating a vector. And what we want for this is just a simple float. A float is just going to give us one value, just like p-scale. Okay, and what this density attribute is going to do is wherever it is set to 1, our scatter is going to create more points, and wherever it's set to 0 is going to create less. And we're going to use the paint tool, and that will allow us to paint where we want the piles of rocks to be. So I'm going to move the attribute expression a bit upwards to add some space, and I'm going to create a new node called paint. So what you can do with attributes is you can paint on them as well. So I'm going to turn on override color, because we don't want to paint the color of this. What we want to paint is the value of the density attribute. So by default, nothing is happening. But if we have the paint tool selected and we're visualizing it, meaning the display flag is set on this node, and then on the viewport we press enter, then you'll see we have a small brush and the whole grid turned purple. What that means is that it has a value of 0. And that's because the visualize mode is set to infrared. So anything that's blue is going to be 0. And when I click on a point, you'll see it just painted that point red. That's a value of 1. Now the reason why this point doesn't look smooth is because the paint is painting on points. And right now, if I show the points, we only have this many points. So we don't have enough to interpolate it. So what we need to do is go back to our grid. And we need to add more rows and columns over here. Let's see, let's try with 50. And now you'll see something interesting happen. When we go back to our paint, even though we had painted there, our paint is gone. It's now showing up over there. The reason for that is that this paint isn't procedural. What we're doing is we're painting on point numbers. If I enable this and I zoom in, so we had painting on point 43 and also a bunch of others. Now that the point count changed, those points are somewhere else. So it's important to know that if your geometry is changing, anything that you paint is going to be lost. On the next lesson, we're going to learn about becks and bobs, and we're going to look at ways of getting around this using our own noise patterns that are independent of the point count. So to reset this, I'm going to click on reset all changes, going to hold shift and drag to make the brush bigger. And now we can start painting. you'll see now we get a lot smoother result. You'll still get these jagged edges, and if you want to get rid of that, we can keep increasing the rows and columns on the grid. There's another thing I want to change, and that is that every time we click, this becomes 1, it's red. So I want to paint with less, I want less opacity. So I'm going to undo this by doing Control-C. And up here, we have a control for the opacity. I'm going to change it to 0.1. Now we'll see when we paint, we get much nicer blending. And we actually have to paint on an area for a while before it becomes red. Once you're done with painting, you can press Escape, and you'll notice that everything turns white. Now, remember we weren't painting on the color. What we were painting was the density. If we look at our geometry spreadsheet now, and we look at our density and we scroll, we'll see there's some areas where the values changed. In fact, we can again just sort by density, and we'll see there's a lot of them that are set to 1. So now when we go to our scatter, we don't have enough points to look at this, but if we increase this even more, we'll see it's only scattering where we painted. So let's keep for now, let's go back to 30 points. And let's get the result. So now we're only getting piles of rock where we painted. So say you want to avoid a part of the environment, or you want to have more piles of rocks in an area, you can always use the paint node, and we can paint where you want the piles of rocks to be. Now that we're getting the hang of attributes, we can push our setup even further. If we take a look at our piles of rocks, you'll notice that now the p-scale is also shrinking them in height. So we have these floating rocks right now. What we actually want the scale to do is to change the dimensions in width and depth, but not in height. And to do that, we need to take our p-scale a step further. The problem with p-scale is that it's setting the uniform scale. If we take a look at the attribute, we'll see that p-scale is a float. A float means any number that has a decimal value. So in this case, we're only changing the uniform scale. If I create a transform over here, and we take a look at the values, when we transform geometry, we can translate, rotate, scale, and all of these are vectors. It's made up of 3 floats. We have values in x, y, and z, but uniform scale is a float. It only has 1 value. So what we want to change is the scale in x and in z, but we want y to remain the same so that we don't have gaps between the rocks. So if we go back actually to, you can select any node and we check the Houdini help again. We can go back to the point attributes by typing point attributes. And we want to go to the copying and instancing point attributes. And in this page, we'll effectively find that p-scale is changing the uniform scale, but there's another attribute simply called scale, which is the non-uniform scale, and this is float 3, meaning that it takes 3 values. So if we go back to our example, and if instead of using attribute scale, we change that to custom, so you'll see that scale isn't here, it only has p-scale. So we'll go back to custom, and we can just get rid of the p. And now it's creating a float. It's still making a float. There's only 1 value. What we want is to have 3 values. We want it to say scale x, y, and z, the same way that p says x, y, and z. So I'm going to change it to a vector. And now we're getting a different value for x, for y, and for z. So if we look at our scene view, our boxes are now different in every axis. But we still haven't fixed the problem with y. And to do that, we need to create a new node, which is going to allow us to edit the scale. And for that, I'm going to create a point wrangle. And this is going to allow us to write Beck's code. Now we're going to take a look at how this works better in the next lesson. But for now, we're just going to write one short line that is going to change the scale value of 1 or y to 1. And for that, I'm going to type @scale. What this is doing is getting the scale attribute, and then we will say scale.y, and that is only getting the y component is equal to 1. And then a semicolon. And there we go. Now scale 1 is set to 1. So if we look at our scene view, now our boxes are lining up, but they still get the different sizes on the other axis. Now there's one more thing I want to change, and that is if we go to the geometry spreadsheet, you'll notice we have scale and p-scale. This isn't ideal because we don't want to have two attributes that deal with scale. This p-scale is coming from the previous attribute expression, the one that's setting the height of our line. Our copy to points is already using that attribute and it's already creating the line. So once this has been created, we can delete that. So to delete an attribute, we can create a node called attribute delete. Just drop it down there. And then p-scale is a point attribute. So I can go over here, choose p-scale. And if we have this node selected and we check the geometry spreadsheet, we will see that p-scale is gone. Now deleting the attribute doesn't mean that the scale is going to change. The only node that was using the scale was the copy to points. The copy to points already grabbed the p-scale attribute, it grabbed the line, and it created a line with different heights. Now that's already done. That p-scale isn't doing anything anymore. So it's always a good idea to clean up the attributes you don't need so that they don't conflict with attributes you might create later on. The next thing we're missing to add to our setup is to rotate every rock differently. And for that, we need to explore the copy to points even further. We learned so far how the position works, and we also learned about p-scale. The last thing we're missing to learn is how the rotations work. And for that, we're going to take a look at a quick example of how the rotations work. I'm going to go back up, and I have one node over here called orientations. And I'm going to hide my pile of rocks, and I'll go inside the orientations. And over here, I made two arrows. First, we're going to take a look only at the blue arrow. So I'm going to bypass the merge. And there's two things that are important. The first one is that the arrow starts at the very origin, which means that the beginning of the arrow will be attached to the point. And the second is that the arrow is pointing towards the z-axis. Now this is important because the copy to points takes the z-axis as the front of the object. And the copy to points is going to match the z-axis with the normal. So if we create a sphere over here, and have a sphere with only one frequency, so it's just very few points, and if we add some normals to it, like creating a normals node, and we're going to change it from vertices to points, and to look at these normals in the viewport, I'm going to enable this, display normals, and we'll see that's the direction they're pointing at. If we do a copy to points, and we copy to these points, and we copy the arrow, we will notice that our arrows are pointing exactly in that direction. If our arrows were facing any other way, I'm going to create a transform, and I'll rotate it, let's say 90 degrees. So if our arrow was pointing there, it would stop matching. And that is because what the copy to points is doing is considering the z-axis of our object as the front, and it's going to match this axis with that normal. So I'm going to delete the last transform. So this is looking good. Now one axis isn't enough to get rotation. We need at least two to get correct rotations. If I unbypass the merge node, we're going to see this is what we have now. And that is, we still have the blue arrow representing the normal. And now we have a green arrow, which is pointing upwards in Y. If we look at our copy to points, we'll see that our blue arrow keeps being aligned, but the green one isn't making that much sense. We can see it's kind of all over the place. In some parts, for example, in here it's pointing downwards, in here it's pointing up. If we want to have our objects be properly oriented, then we need to provide our points with a normal and with a second vector, which is called the up vector. And the up vector represents what side is up in the object. Now there's one thing to take into account when dealing with the normal and the up vector, and that is that the angle between those two vectors needs to be 90 degrees, exactly like here. If the angle isn't exactly 90 degrees, you're going to get the wrong results. So let me show you how that would look. I'm going to go back to our normal, and I'm going to create a new attribute expression. We will drop it down, and in the drop down, we're going to select custom, because there's no up in here. we'll change it to up. That's the way this is an attribute that again Houdini is recognizing. And we will change the preset to constant value. And we will set it by default just to be 0, 1, 0, which means it's going to point up. And if we look at this, we'll see that nothing changed, but our geometry spreadsheet will have a new up attribute that is effectively pointing up in Y. It's hard to tell what a vector is looking like just by looking at the geometry spreadsheet. It's always a lot easier if we can look at it on the viewport. Like right now, we have no way of knowing if the angle between the up and the normal, which in this case is shown by these blue lines, is going to match. In Houdini, we can create our own visualizers and we can visualize our own attributes. For that, I'm going to press the letter D for display while the mouse is on the viewport. And I'm going to go to visualizers. And here there's a plus, and I'm going to create a new marker. Here I'm going to create a name. This can't have any spaces. So I like to call it the same as I'm going to call the attribute. Now the label that says marker 1 is the name that's going to be here. We can have spaces in there. You can call it anything you want. Call it up. And then the attribute is the attribute that you want to display. In our case, it's up. And we don't want to have text. We don't want it to say, right now you can see there it says 0, 1, 0. What we want is to have a vector. And we can change the color. I like to change it to green. So that's the same color that Y has. And the last thing I'm going to do is you will see that they're very long. Houdini is by default, if I go back to guides, is scaling the normal by 0.2. So I like to have the length scale be the same, 0.2. And this way, our up and our normal have the same length. So it's easy to compare them. So right now, these obviously don't have a 90-degree angle. So let's have a look at what happens when we try to copy points when our up and our normal are at 90 degrees. And we'll see that again, this isn't aligned. The arrow should be pointing where the blue line is, and the green one should be pointing where the green one is. This case is up, and that's not happening. Now, trying to figure out what the value of up should be so that it's 90 degrees would be very hard. So what we have to do is get another vector that is 90 degrees. So what we're going to do is use a function called the cross product. And what the cross product does is it takes two vectors. In this case, it's going to be our normal and our up. And it returns a third vector that is perpendicular to both of them, meaning there's 90 degrees to both of them. In that case, it would give us something like that. And what we can do with that is make that vector be our new normal. So let me show you how that would look like. I'm going to visualize our attribute expression. And we have the up vector here. Now, I don't want to change the up. I want every arrow to be pointing perfectly up. I just want the blue arrow to be pointing in a random direction, but always perpendicular to this line. And to do that, we need to change the normal. So for that, I'm going to create over here in attribute expressions. I'm going to click on the plus, and that's going to let us create another attribute. And I'm going to change it from P to normal. And I'm going to type in here, I'm going to delete the expression. Actually, we can leave it. I'm going to the vex expression, and I'm going to type cross and open parentheses. And we'll keep this self. This self represents the current value. And then we will do comma at up to reference the up attribute. And if we do enter, and when we look at this, we can see that the normal is perpendicular to the up vector. And if we look now at our copy to points, we'll see that our two arrows are matching perfectly. Let's have a look at another part like this one. And this is effectively matching. So now we need to go back to the points in our piles of rocks, and we need to create an up vector. And then we need to create a random normal that is going to be perpendicular to the up. And the way we do that is by using the cross product. So let's go back to the object level. Let's enable our pile of rocks, and let's go back inside. And I'm going to visualize our last point wrangle. Okay, and if we look at our geometry spreadsheet, we'll see we don't have any information for the orientations. And actually, I don't want to keep switching between the geometry spreadsheet and the scene view. So for that, we're going to add the geometry spreadsheet in here. I'm going to click on this drop down arrow and I click on split pane top bottom. And then we're going to right click on scene view and we will change it to geometry spreadsheet. Okay, and now we have our handy geometry spreadsheet in here, always available for us. I strongly recommend always having the geometry spreadsheet open so you can always have a look at what's going on with your attributes. So we know that the first thing we need to create is an app vector. And for that, we can keep using this attribute expression. I'm going to click on plus, and we're going to create a custom attribute. We'll call it app. And we will change the preset to be constant value. And let's change it to 0, 1, 0. And right now we have this pointing perfectly up, which is correct. If we look at this, the way we align our box, that way is up, so that's correct. The next thing we want to do is create a random normal. So for that, I'm going to press plus again. I'm going to select the normal. And in this case, we're going to choose random. Now, this is giving us a random normal, but it's still not perpendicular. So remember, to get that, we need to do cross product of this with up. So we can simply do cross product by tapping cross. I will open parentheses, and we need to have one vector that's going to be, that's the current value for our normal, comma, and then add up to reference our up attribute. There we go. Now our normal is perpendicular to the up, and we can see it's pointing in different directions. So let's have a look at how this looks. And I'm going to turn off for now the display normals. And if you scroll down, we can turn this off. That's the visualizers. And I'll turn off these points as well. So now our boxes are getting different sizes and they're all getting different orientations. The last thing we're going to do before moving on to the next lesson is change the shape of the rocks so that it looks something more like a piece of rock than actually just a simple box. So for that, we're going to edit our box. So I'm going to zoom into it by pressing H. And the first thing we need to do if we want to give it more detail is add more subdivisions. So for that, I'm going to use a node called remesh. And what this is going to do is triangulate the geometry. And it's going to create edges that have by default a length of 0.2. So if I create edges that are smaller, we'll get more triangles. You will see this is changing our shape. So if we want to keep our hard edges, we can say here in the hard edges group, we'll press star, and that means all. That means keep all our edges the way they were. The next thing we'll do is smooth out the edges. So I'll create a smooth, just so it doesn't look perfectly straight. Let's look at the result. And that's maybe too much, so we can change the strength. Right now it's set to 10. Maybe something like that, 2.7. And then the other thing I'm going to do is I'm going to change the selection. I'm going to make sure this is set to points. And we're going to start selecting some of it and moving it just to get a more interesting shape rather than just a simple square. So this isn't procedural, but it will do for now. I'm going to press T on the keyboard to translate. I'm going to start moving the points. And you'll see right now it's just pulling everything. I want to use the soft radius. So if I scroll down, we'll find here the soft radius and we can increase that. You can see now everything is moving. And I just want to move, I don't want to change on the y-axis. I just want to move it in C and X. So maybe something like that. We'll just try to get a more interesting shape. Oops, we can Control C to undo. We'll move these ones like that. Maybe increase this a bit more. We'll push these points there, these ones there. Let's see, something like that. Now it looks a bit more interesting. And lastly, the very last step we're going to do is we're going to use the mountains node, which is going to deform it even more. So I'll create a mountain. We'll connect it here. And by default, it will look crazy. That's because it's creating too much. It's adding too much noise. So for that, I'm going to bring down the height. The height is how much noise we're adding. And the other parameter I want to change is the element size. And that controls the pattern of the noise, how big it is. You can see right now, if I change back the height, it's mostly changing it in two areas. I want to have a very high frequency. So I'm going to lower it. I want to have like a subtle noise on top. Maybe something like that. And then I'm going to add one last smooth, so it doesn't look that rough. Not that many. Maybe just 0.1. Let's see, 0.2. Okay. We can even, if we want to have more detail after this, we can add another remesh. And the reason why I don't change the remesh above is because this edit isn't procedural. And that is actually grabbing these point numbers and it's moving them. If we change the remesh, we're going to change our point count and then the edit will break. So that's why we can do it afterwards. Just keep lowering this even more. And I will set it to hard edges all. Okay, let's look at the result of the mountain now. Cool. Let's smooth it. We can smooth even more. I'm just not that happy with this thing that looks like a sphere, looks like a ball. Just we can just go back to the edit, select these points and move them in a little bit more. Something like that. Okay. Let's see what it gives us now. Perfect. And I think now actually the mountain might be a bit much, so let's use less of the height. Let's see, maybe even less. You can even reduce the element size, 0.7. All right, yeah, this is a rock that I'm happy with. So now when we look at the result, it's starting to look more like rocks.